Section 3.3 is linear functions and data. So if we're given a table of values, we already saw in chapter 2 that we can see whether something's a function or not, right, by scanning the x-coordinates and seeing if any values repeat themselves. But how do we determine if a table of values is linear? So they have to have a constant average rate of change because the slope of a line never changes. So if we look at this data, right, if you just try to plot these points, things can look linear and they might not actually be linear. So we actually have to verify that it's a constant ARC. So one way we can do this is we can calculate these ARCs all at once. And the way we're going to do that is the following. So the first thing I'm going to do, I'm going to move this up a little bit so we can see the table, is I'm going to go to Stat right here on your calculator. Right above Stat is List. Okay, so I'm going to press that, and then you're going to see Edit. And when I hit Enter, my list comes up. So I'm going to put the X values in column 1. So it's 5, 10. So you just hit the value and hit Enter. 15, 20, 25. Then I'm going to put the corresponding Y values in L2. So 2.46. 3.81, 6.43, 7.78, and 9.19. So I'm just going to verify that those are correct, and they are. So now what I can do is I can actually make the ARCs appear in column 3. So in column 3, I want to do the change in the Y over the change in X. So to get delta list, which is what we want, we're going to hit second list, which is above the stat button. And then we're going to go to ops. Oops, excuse me, let's quit that. I hit the wrong button. Let's go back to list, edit. I have to be in this, you have to actually highlight L3 because I want the formula to go here. And I'm going to go to second list, ops. And then I'm going to scroll down, and number 7 is delta list. So I'm going to grab that, and then I'm going to put L1. So there's a shortcut to grabbing L1. So if you look above your numbers, right, you see L1, L2, L3. So if I hit second 1, now it's put L1 in that formula. So it says do all this, right? But we actually want to do Y over X. So I need to do second 2. There we go. Close parentheses. Then divide, and then we're going to go back to second list ops. Number 7 is delta list again, and now we're going to do second L1. So this is saying take all the Y values and change them over all the X values. So now when I hit enter, it fills in all the ARCs, and you see you have the little dash line because you have to compare 2 points, right? And this guy's already been used up here. So these should all be the same if this function's linear, and they are not the same. So our conclusion for the first table is no, this is not linear. Now let's compare the second table. So I'm going to go over, and since my X values were the same, I don't have to adjust those, but I'm going to put my new Y values in. So that's 5.53. 8.04, 10.55, 13.06, and 15.57. Now notice over here these numbers didn't adjust while I was doing that, so I actually have to go in and tell it to recalculate my ARC. So unfortunately it doesn't have the formula in there anymore, so I need to clear. Hit enter, so we've cleared it out, and now highlight L3 at the top, and once again I'm going to go to second list ops delta list second L2 close parentheses divided by second list ops delta list again second L1, and now we see that it's pretty close. We have like 0.51, 0.494, 0.502, 0.502. So I would say this is pretty linear. I mean, it should be exact, but, oh, and the reason it's not exact is I see I typed a number in wrong. So if you look right here, 8.08 should have been 8.04. Some of you are probably screaming at the screen. So let's see what happens when we recalculate this. Oops. All right, let's try this again. Second list, ops, delta L2, divided by second list, ops, delta L1. Bam, now they're all the same. So this is definitely linear. ARC is constant, and it equals 0.502. So that's actually our slope. So now we can simply say, well, we have to find the equation of the line, right, if it's linear. So we know A is 0.502, and just like we did for our piecewise function, we know our function has got to be of this form. So I can grab any data point off of this list and plug it in for y and t and get my value. And I actually should probably call this x since these were x and y. So we can grab the first point here and say 5.53 has to equal 0.502 times 5 plus b. And when I subtract this, I get 3.02 equals b. So our linear model, y as a function of x, is 0.502x plus 3.02. So it's not truly linear unless they were all exactly equal. So we got close, but you got to make sure you don't type your numbers in wrong like I did.